whenever you have an aldehyde or a ketone, if you have an alcohol in the presence of an acid, then that's going to enable the generation of the acetyl group. If you have an alcohol in the presence of an aldehyde or a ketone, then you're only going to be able to establish a hemiacetal for an aldehyde, and for a ketone, you're going to generate a hemiketal. And so it's pretty simple in that the reaction proceeds via a nucleophilic addition elimination sequence. And only under acidic conditions does the oxygen that gets protonated into a hydroxyl group get protonated again, which enables the hydroxyl to become a good leaving group, and so enabling the other alcohol of the same type to establish a sigma bond in place of the hydroxyl. And furthermore, you should know that whenever you have an alcohol or an acid, in reference to generating acetals, that's only going to be possible for aldehydes and ketones, so make sure that you know that. And again, the bigger purpose is so that you're able to establish a protecting group, which preserves the identity of the carbonyl after you have an acidic hydrolysis, which reverts the acetyl back into its original carbonyl form, which would correspond to that of either a ketone or an aldehyde. And again, the bigger picture here is to say within the same molecule you have a reduction, or in the context of an aldehyde you have an oxidation that you want to prevent the aldehyde from getting oxidized into a carboxylic acid. Then it should make sense that in converting the aldehyde carbonyl into an acetyl, you prevent those reactions from occurring. And then such would be the case in the example of, let's suppose, 2-butanal, or I should say 2-hydroxybutanal, where you would want to oxidize the hydroxyl group, but not the aldehyde, into a carboxylic acid. And so you should know that the oxidation of a secondary alcohol is going to generate a ketone. And so this reaction would enable the generation of a alpha keto aldehyde molecule after you hydrolyze the acetyl group back into its original aldehyde. And again, the more common example is going to be that of preventing the reduction of aldehydes or ketones. And that if you have lithium aluminum hydride, or even sodium borohydride, which is a mild reducing agent, but is one that is able to nonetheless reduce ketones and aldehydes. And so suppose you have an acyl chloride of a compound which constitutes an aldehyde as well as a acyl chloride, or a ketone and an ester. If you want to have a selective reduction occur, then what you do is you protect the ketone or the aldehyde in the form of generating an acetyl with, again, an alcohol and a strong acid. And then subsequent reduction with lithium aluminum hydride would enable the reduction of the ester group, or in the previous example with the aldehyde and the acyl chloride. Then again, if the aldehyde is protected, you can use sodium borohydride to reduce the acyl chloride into a primary alcohol, which after protonation is going to yield you the hydrolysis of the acetyl, which reestablishes the carbonyl in the form of an aldehyde. So again, these would be common examples, or I should say practical applications, outside of just having to memorize the aldehydes and ketones generating an acetyl group. And so it should make sense that if you have half of an acetyl, we refer to that as a hemiacetal. If you have a hemiketal, that corresponds to the precursor molecule being that of a ketone, obviously. And again, the way that you can identify these reactions in reference to the products is that if you have a carbon that is simultaneously bonded to a hydroxyl and a ether group, then that would correspond to a hemiacetal. Or in the case that you have 2 alpha carbons and hemiketal. So make sure you know the difference. I should say, though, commonly is the case where hemiketals are referred to as hemiacetals altogether. The more specific and precise term would be that of a hemiketal, but just know that it is a possibility that you could see a question that asks you which of the following would generate a hemiacetal. And then what you're going to do is select any reaction that has the ketone or aldehyde in the presence of a alcohol, which enables the generation of the hemiacetal. Now, the other thing to know is if you have